Hi guys, this was the lowest scoring AP Calculus BC question, FRQ from 2025, and this had an average of just 3.09 points out of 9 points. The other questions had an average of around 5 to 6 points. So let's see what we're dealing with this time. So we have a polar equation. We have two polar equations actually. Of one that's given by r of theta is equal to 2 times sine theta squared, and the other one, which is r equals 1/2. Now, let's quickly identify these two polar curves. So this one right here, this is the r equals 1/2. And this kind of oval shaped polar curve here, this one's the r equals 2 sine theta squared. Okay, let's move on to the parts. So starting with part A, the question says, find the rate of change of r with respect to theta when theta equals 1.3. So what's the formula for finding the rate first of all? So we know that we're given that r is equal to 2 sine of theta squared, and then we have to differentiate it with respect to theta. So we have dr d theta is equal to, so using chain rule, 4 sine theta times the derivative of sine theta, which is just cosine theta. And we have to evaluate this. The question says we have to evaluate this at theta equals 1.3. So we plug this into our calculator, dr d theta at theta equals 1.3. This turns out to be 1.031. Simple as that. Moving on to part B here. Part B asks us, find the area of the region that lies inside curve C, but outside the graph of the polar equation r equals 1/2. So basically what the question is asking us to do is it's telling us to find this area right here. All this area right here. Now we have to exclude this area because the question says we must find the area outside the graph of the polar equation r equals 1/2. So not including this area, not including the area equals 1/2. Well, how do we do that? Well, the equation for finding area is the integral from the two endpoints a to b of the outer polar equation. Let's just call it r1 squared minus the inner polar equation, which is r2 squared d theta. So if we use the same formula, we can see that r equals 2 sine theta squared. This is going to be the outer region. So we're going to take this region here, this entire region right here, and we're going to multiply that. We're going to square it, and then we're going to subtract it from the area of this inner polar equation right here. So how do we do that? Well, we have 1/2. Remember, we must have 1/2 always. 1/2. Now we have to first find when these two polar equations are equal to each other. So we have to set it, right? So the first polar equation is 1/2, and the second one is 2 sine theta squared. Now, if we divide by half, we get 1/4 is equal to sine theta squared. Take the square root, so we get 1/2 is equal to sine theta. And from the unit circle, we know that sine theta, or sine, is equal to 1/2 at when theta is equal to pi over 6, and theta is equal to 5 pi over 6. So now we have our two endpoints. So we can say from 1/2 of the integral from pi over 6 to 5 pi over 6. Now, let's look carefully. Our outer function is going to be 2 sine theta squared minus our inner function, which is 1/2. So we have, remember to have parentheses here, 2 sine theta squared minus 1/2 squared d theta. And if we evaluate this function, it's going to give us around 2.067. Now, moving on to part C here, the question asks, it can be shown that dx d theta is equal to 4 sine theta cosine squared theta minus 2 sine theta cubed for curve C from theta equals 0 to theta equals pi over 2. Find the value of theta that corresponds to the point on curve C that is farthest from the y-axis and justify your answer. So we have, this is kind of basically like another candidates test, so we're given the x function of the polar curve of the curve C. So we know that x is equal to r times cosine of theta. So what is r here? Well, we're given r, right? R of theta is equal to 2 sine theta squared. So we know that x is going to be 2 sine theta squared times cosine theta. Now we already have dx dt here. If we take the derivative of this function here, the question already gives this to us. We know that that's going to be here, and we can set this function equal to 0 so we can find critical points. So we set dx dt equal to 0, and when dx dt is equal to 0, theta. So remember, guys, we have to set this function here, this function equal to 0. So theta is roughly equal to 0.955. So now we have our candidates. So we can say theta. I'm just gonna make another table here, and x of theta. We know that x is equal to 2 sine squared theta cosine theta, and we have to have our two endpoints, right? So the question says the two endpoints are 0 and pi over 2. So we have to have 0, and we have to have our critical point, which is 0.955 and pi over 2. Now, if you put this in, 0 is going to be 0, and pi over 2 is going to be also going to be 0. But if we put 0.955 in, x ends up being 0.76980. So therefore, the furthest point occurs at theta equals 0.955. So the value of theta for which the curve is furthest from the y-axis is 0.9955. It's a little hard to see there. Now, on to the last section, which is part D. The question asks, particle travels along the curve C so that d theta over dt is equal to 15 for all times t. Find the rate at which the particle's distance from the origin changes with respect to time when the particle is at the point where theta is equal to 1.3 and share the calculation for your setup. So now this is a chain rule problem. So let's map out what we're given first. So we're given d theta over dt is equal to 15. And you're asking for the rate at which the particle's distance from the origin changes. So distance from the origin, the distance from the origin is r, and the rate at which the particle's distance from the origin changes is just dr over dt, right? That's taking the derivative of the rate, which is the distance of the rate of the distance. So dr dt is equal to dr over d theta times d theta over dt. The d theta cancels out here, so we get dr dt is equal to dr dt. But dr dt here, we already found that dr from part A here, as we can see, part A, we know that dr d theta is equal to 4 sine theta cosine theta. So using that in this problem here, we have dr dt is equal to dr d theta, dr d theta, which can be substituted for 4 sine theta cosine theta times d theta dt, which we just know from the problem. It says it's 15. And the problem tells us to find the rate at which theta is equal to 1.3. So now we can just substitute theta equals 1.3. So dr dt at theta equals 1.3 And if you put this in your calculator, this ends up being 15.465, and that's your answer. And that's it. This was the hardest problem on the AP Calculus BC exam in 2025, and I hope you enjoy watching. If you have any suggestions or how I can improve my videos, please let me know in the comments. Thank you.